Hi, and welcome back to R for BRFSS. I'm Jennifer, your instructor for this tutorial series. The last time we met, we wrapped up our segment on market basket analysis. Over the next 3 videos, we're going to be working on some logistic regression analysis. So we'll start by cleaning our data, then analyzing it, and then visualizing it. For today, we're going to read our article, subset our data file, and then clean our data. The article that we're working from is called Correlation Between Physical Activity and Self-Rated Health Status of Non-Elderly Adults with Disabilities. And again, this article is not available for free online. You can only access it for free if you have a subscription to that journal. I got the article through my university library system. So if you need a copy of the article, just go ahead and send me a message and I'll send you a copy of my PDF. But I have it on my desktop. Let's get started. The reason why I chose this article is because the first word in the title is correlation. And I do a lot of correlation analysis on my own research, so I thought this is going to be such an easy article to work from because I already know how to do correlation analysis. But then I was also intrigued because we know that the BRFSS data, most of it is categorical, right? All of our values are actually factors. And when I've done correlation analysis in the past, I've used continuous variables. So they're actually numbers that we do math on. So I was kind of intrigued by this title, Correlation Between Physical Activity and etc. And then when we look into the abstract, they describe that they do a multivariate logistic regression analyses, which is not quite the correlation that I thought of. So then I was even more intrigued because I've conducted regression analysis in the past, but I haven't had a lot of experience doing logistic regression analysis on big survey data like BRFSS. So I was really interested to start working on this article. Anyway, a couple of things that they do is they subset their population to adults with disabilities. And they're working from the BRFSS data in 2007. So yeah, the 2007 BRFSS data. And they subset their population according to these 2 questions. So are you limited in any way in any activities because of physical, mental, or emotional problems? So they included all people who responded yes to that. And then of those people, excluded people who also said yes to do you now have any health problems that requires you to use special equipment such as a cane, a wheelchair, a special bed, or a special telephone. So since we're working with the 2017 BRFSS data, I checked on those variables in the codebook. So CDC, BRFSS 2017. Go to our BRFSS survey and data and documentation. Go to the codebook. And to search for those questions, I looked for a couple of keywords. First, I looked for the question, are you limited? So that didn't produce anything. Then I thought to search for physical, mental. So here's one. I did get a hit when searching for physical, mental, or emotional. In the paper, they call it problems, but in the 2017 BRFSS data, the question is because of a physical, mental, or emotional condition, do you have serious difficulty concentrating, remembering, or making decisions? So this is kind of a question related to disability, and there are actually, as far as I could tell, 4 questions in the 2017 BRFSS data related to disability. So this one about having problems making decisions. Let me make that a little bigger for you. All right, and then do you have serious difficulty walking or climbing stairs? So this is also related to disability. Do you have difficulty dressing or bathing? And then because of a physical, mental, or emotional condition, do you have difficulty doing errands alone, such as visiting a doctor's office or shopping? All right, so in the 2017 BRFSS data, we have 4 questions related to disability, but as you can see, they're quite different than the questions that the authors used in this paper to define their study population. So we're just not going to worry about that disability variable and just continue with our analysis without limiting our population based on disability status. All right, so, but let's see. The variables that they did include, which we'll also look at, are in this measures section. So they looked at SRH, which is self-reported health, and that's that X_RF health variable that we've been looking at, which is, let me just show it to you, _RF health. Oh, that's not an underscore. _RF health. So this is the variable that's calculated from the general health question, and it divides responses between good or better health, or fair or poor health, and then don't know, not sure. So in the article, they look at self-rated health. That's that describing the health as excellent, very good, or good, fair, or poor. That's their main dependent variable. Their independent variable is leisure time physical activity. And they actually look at leisure time physical activity. They put it into 5 categories. So they are, maybe it's, yeah, here we go. Based on these criteria, we categorized, physical activity was categorized into 5 discrete levels. So they categorize them according to these 5 levels. So I was looking in the BRFSS survey for a similar or comparable physical activity question. So back to the codebook. I searched for physical activity, and I got 73 results, which we've spent enough time together that, you know, I really don't like scrolling through long lists. I really don't like this kind of data digging, and I confess I'm a little bit lazy. So when we're looking at this physical activity variable, we'll be working with the physical activity variable that we've used in our previous segments, which is this one called _Totinda. And this looks at adults who reported doing any physical activity or exercise during the past 30 days other than their regular jobs. So we just have 2 categories instead of 5. The one is, category 1 is I did exercise at all in the last 30 days. The other categories are I did not exercise at all during the last 30 days, or don't know, refused, and missing. Okay, so we're simplifying it a little bit. Let's close that. Back to the article. They conducted their analysis in Sudan 9.0.01. We're, of course, using R. And they looked at a number of covariates, which they describe here. 11 potential confounding variables. So they included age, actually as a continuous variable. They looked at smoking, healthcare coverage, gender, income, education, heart disease, arthritis, asthma, diabetes, and BMI. All right. And then when they described their analysis, they wrote that they conducted chi-square test and logistic regression analyses, but actually I don't think they conducted chi-square, or maybe that's how they derived their p-values, but later on, looking at this table, right, so the table should display the results of their statistical analysis, right? So the title of their table then is Bivariate Associations of Self-Rated Health Status with its Covariates and Logistic Regression for Fair or Poor Self-Rated Health Status, etc., etc. So when we get to the data analysis video for this segment, I'll show you how to conduct a chi-squared test, but they may have conducted chi-squared tests, but that's not what they displayed in their table, as far as I can tell. So when we do our analysis, we'll focus on just trying to duplicate this table. All right. Now, again, something that's frustrating to me about this article and a lot of articles is that they reference BRFSS variables from the codebook and from the survey, but they, of course, don't describe the exact variable name. So again, I had to kind of do some matching, and I did my best to match up all of their variables with all of their health indicators with the variable names. And then I looked at the value of the variables that they set as their reference for their logistic regression analysis, and then those are the variables that we wanted to recode to 1. But actually, I ended up calling them ref for reference, just because visually it was easier to see the difference between reference and comparison than between 0 and 1. So anyway, these are their health indicators. These are the variables that we pulled out of the BRFSS survey. All of them were considered factors except for age, which they set a continuous variable between 18 and 64. Okay, so can you see all of those? Right, so let's get started with R then. Since we've kind of read our article, we'll keep reading the article, but it will be easier if we're already in R and working with our data. So set the cran mirror to the cloud, set our directory to R for BRFSS, okay, and usually I print out my notes for my code and I pretend like I'm doing everything from memory when I'm typing stuff into the R console. But my printer ran out of ink, so I wasn't able to print my notes. And actually, it's really hard to give a tutorial and also remember what your code is. So I'm just more or less going to be working right from my Word document that has my code on it. All right, so this tutorial segment will be a lot less typing and more me kind of walking you through the code that I already have written. All right, so I hope you're okay with that because, you know, if I tried typing, I would make so many mistakes because I don't have the code in front of me. So that's what we're going to do for today. First, let's load the tidyverse. Library, tidyverse. And we're still working from our California Girl 17 CSV file. So I'm just going to go ahead and read that in. That command is read.csv. Let's glimpse it, California Girl 17, to make sure that it looks like what we're used to seeing. All right, yep, so all 9,355 of our observations, all 240 of our variables, that looks good. Now we want to subset this data file. I've called it CG17_LR for California Girl 17 logistic regression. And we are subsetting this by using the select commands. Subsetting the California Girl 17 data file using the select command and including all of our health variables. And we'll also be working with the weighted survey sampling frame today as well. So I've included the variables that we need to include when we set our survey design. So 13 health variables plus the 3 weighting variables is 16 variables total. So let's just run that command. Oh, can I make this? That's fine. Okay, let's take a glimpse. CG17_LR. Right, so we still keep all of our observations and we have 16 variables. Now what we want to do is we need to recode. Of course, we need to recode our variables because now R recognizes them all as integers and it's reading the numbers, 2, 1, whatever the response value options are. But we are going to recode everything and then set the appropriate response value to reference. So in the article, in the table, they did odds ratios and adjusted odds ratios, and for each variable, they have a reference. So we're going to set all of the response values for the health variables that they used. We're setting that reference. We're going to call it REF for reference. You see? So they do that across all of the variables. Each variable has a reference because these are odds ratios, of course. So that's what we're going to do. But before we do that, one of the specifications that they set on their study sample were adults between 18 and 64. So we actually have one more subsetting to do, which I almost skipped over, is we need to set our age. That variable was age G 5 year. We need to set our variable to only the age, people's responses to age that are less than or equal to 9. And that's because in the codebook, age G 5 year, that variable has 14 different categories in it, and they're separated by 5 years. So it's not actually a continuous variable, but the authors are treating it as a continuous variable, so we'll just do the same for now. And they included all responses up to age 64. So response option 9 is 64, and then it starts at response option 1, people 18 to 24. So we want to subset our data file to people under 65 years old. So in order to do that, we run this command where we filter out where that variable is less than or equal to 9. All right, and then let's glimpse it again, cg17_lr. And we keep all 16 of our variables, but our number of observations decreases because it removed all observations who responded to that age question at 10 or greater. So these are only people in the age categories 1 through 9. We have about 7,000 respondents left. Okay, now for cleaning our data, we've done this a lot of times before, and I've walked you through it so many times. You know what we're doing here. We're setting the variables that should be factors as factors and recoding the response values to what we deem as appropriate based on the article that we're mimicking our analysis from. So as I said, in the table, the authors describe which values are their reference value. So we're setting that value to reference. And then if you haven't seen the previous videos, just to bring you up to speed, this value 1, so for example, for x_rf health, the value in the BRFSS codebook, the response option 1, is somebody with good or better health. And so we're setting that as our reference. And then we want the default and the missing, so everything else to be com, which is comparison. So we have the reference and the comparison. And we do that for all of our health variables, for RF health, exercise, smoking, healthcare coverage, sex, income, education, cardiovascular disease, arthritis, asthma, diabetes, and BMI. The only one we're not changing as a factor is the age variable because they kept it as continuous in their analysis. So we're not setting that as a factor. So let's go ahead and run these commands. And I don't see any errors, so hopefully it worked. Let's check it out. Glimpse cg17_lr. Oh, cg. Yep, we still have all of our observations, all of our variables. We can see comref for reference and comparison, factor, everything's a factor except for the age. The age variable is still an integer, and our weighting variables, we didn't bother with cleaning that data. It's fine as it is. But I think it's not super intuitive to do to calculate odds ratios on a continuous variable because they didn't set a reference value on their age variable, right? So I wanted to look at the distribution of the age. So first I looked at the count. This is this count function, which we've used in previous videos, on the age variable by their health status. So I just kind of wanted to look at the distribution of that data because they're claiming it's continuous, but we know it's actually categorical. So the comparison and the reference here are the actual numbers, but it's kind of easier to look at it on a histogram. So we're using the ggplot function to create our histogram. The data set is California Girl 17 underscore logistic regression. Our aesthetics are X is that age variable. We're filling it by the health status question. We're using geom underscore histogram, position equals dodge. That just means that it will separate the bars according to, it won't stack the bars, it will put the bars side by side. And then bins, the default for bins is 30. We can change this number to anything we want to, but I don't want to change it. I just wanted to let you know that if you did want to change the bins option, you could change that number. Let's run our ggplot commands. That didn't work. Why didn't that work? Let's see. Oh, it did work. All right. So yeah, so if we look at the distribution of age by health status, we can see that people at, so blue is the reference. These are people with good or better health. So you see there's kind of this, I don't know, maybe quadratic relationship, I don't know, like this. But we can see that the people reporting the best, the highest frequency of people reporting good health are at this age category 1. So what we're going to do is we're going to keep the age G 5-year variable as continuous, but create another age variable that's categorical, where our reference value are people at the age category 1, because these are the people reporting the best health. So they're our reference, they're our standard for a good health. Okay, so let's run that code. And we're setting it as a factor, recoding the value 1 to reference and everything else to comparison. Go ahead and run that. Let's check out our data file again, cg17 underscore lr. All right, and now you see at the bottom of our data file, we have this age variable, which is our categorical age variable, where the response value 1 is our reference and everything else is comparison. So we have 17 variables, and we still have all of the observations that we had in our previous call. Okay, so I think our data is cleaned. Yep, so our data is clean. I'm going to keep my R session open and just stop the video now, but then pick up where we left off, and we'll start by studying our survey design, so working with the survey weights, and then we'll start doing some analysis. All right, so I'll see you back here very soon. Bye!